Welcome to ZeroDown Software's video series. Deploying a ZeroDown software sandbox environment. In this video, we will review the components required to build a ZeroDown software sandbox environment, present an operational overview of the ZeroDown sandbox, review the configuration of ZeroDown software, and close with validation testing and demonstration of ZeroDown software. A ZeroDown software sandbox is comprised of a deployment of ZeroDown software and two deployments of the ZV sample application. Separate videos demonstrate the deployment of ZeroDown software in the ZV sample application. ZeroDown software is designed to replicate transactions to two or more application endpoints in a highly available environment. As depicted in the diagram, a transaction is sent to an application, as an example ZV sample 1, and replicated to a secondary application ZV sample 2. ZeroDown software provides application resilience. In this case, if a site is offline, in this example application ZV sample 1, the transaction can still be processed through application ZV sample 2. The user never encounters downtime with the application. Configuring ZeroDown software is intuitively done through the management console. Using a web browser, connect to the server running ZeroDown software through port 9001. Log in with the user admin and the password configured during the installation process. Once logged in, the administrator will be presented with a ZeroDown dashboard. Note, since the application endpoints have not been configured, services Node 1 and Node 2 are in a down state. Now, let's configure the applications. Clicking on the Settings option, we will enter the Services setting page. In the General tab, the first three entries will identify the site and the security URLs. As a reference, additional documentation can be found on the ZeroDown software website. Under Resources, Quick Start Guides, select the HA for Cloud Quick Start Guide. In the appendix on the last page of the document, are the entries required on the Settings tab, the server name, which can be anything of your choosing, and the security URLs used in the sandbox configuration. Back in the Management console, create a server URL name. This could be an actual FQDN name or in this case test.com. Using the Quick Start Guide as a reference, copy and paste the entry for security URLs. Now do the same process for the logout URL. The security URL and logout URLs are used to track active sessions during operations. Once the entries are completed, hit the Apply button in the upper right. This will save your entries and reload the services. Now, let's configure the application endpoints. To start, we will select the Node tab in the Services setting page. For this task, we will need to have the addresses for the two ZV sample application servers. The addresses can be IP addresses or a DNS entry. In our example, the two ZV application servers are addressed as zvsite1.local and zvsite2.local. The application communicates through port 8080 and the protocol is HTTP. Once all the node entries are completed, click on the Apply button on the upper right and approve. Now we can go back to the console dashboard by selecting the Home option. The dashboard will display the status of the ZeroDown software services. If needed, hit the Refresh button on the upper right to update the status of the services. With a successful configuration, all the services should be listed as up. We will now test and demonstrate ZeroDown software in action. In the browser, alongside of the ZeroDown Management console, we will create new tabs for the two ZV sample applications, and a tab connecting through ZeroDown software. Our first tab will open up a page to the first ZV sample application. In our example, we connect to the zvsite1.local URL, using port 8080. We can now log into ZVSite1 using the credentials demo@demo.com, with the password of demo1234. When prompted for an encryption key, it is simply 1234. This tab is now logged into ZV sample site 1. In this site, We differentiate Site 1 and Site 2 with different images. In Site 1, we use the logo for AWS. Our next tab will open up a page to the second ZV sample application. In our example, we connect to the ZV site2.local URL, also using port 8080. Log into this second site using the same credentials demo@demo.com, with the password of demo1234, and again when prompted for an encryption key, it is 1234. In Site 2, we use the image for Microsoft Azure. Finally, we will open a tab connecting through ZeroDown software, in our example ZDS22.local using the HTTP protocol. We are now connecting through ZeroDown software to the applications. We will begin by logging into the application, using the same credentials, demo@demo.com with a password of demo1234, and again when prompted for an encryption key, it is 1234. Once we've authenticated, we notice that the AWS logo is presented. This displays our persistent session as through ZV Site 1. It basically signifies which system provides the persistent interactions with the user. To begin testing ZeroDown software functionality, we will go back to the tab for ZV Site 1. We can monitor transactions into the application by selecting the Contacts tab. We will now do the same with the tab for ZV Site 2. Once again select the Contacts tab. We will now demonstrate ZeroDown software's active-active functionality. Selecting the tab for ZDS22, we will select the Contacts tab. Let us add a new personal contact. We will use my new friend as an example. Returning to the Contacts tab, we can see that my friend entry is now in my personal contacts. We will now look at ZV Sample 1 site, and we see that my friend is entered in the personal contacts list here. Taking a look at the ZV Sample 2 site, and we see that my friend has been replicated in the personal contacts list here as well. Going back to the Browser tab connected to ZeroDown software, we will display the ICE tab to display the summary information and the persistent session. Again, we confirm that the persistent session is to the site with the AWS logo. We will now emulate an outage by disconnecting the AWS site, ZV Site 1, on service node 1. This is accomplished by hitting the shutdown button on the node 1 line. Once the dashboard refreshes, we can now see that node 1 is down. On the dashboard, the shutdown and restart buttons represent ZeroDown software's circuit breakers. The circuit breaker connects or disconnects transactions to that node. The circuit breaker can shut down a node manually as just demonstrated, or if a heartbeat function determines that the application is not responding. Once a circuit has been tripped, the only method to restart is manually or through a remote management request. Remote management requests are performed through REST services APIs. To enable this, administrators need to create an API token. The token can be configured with various expiration options. Finally, we begin demonstrating the benefits of ZeroDown software's active-active environment. In the Browser tab connecting to ZeroDown software, we will start an automatic refresh utility. This will automatically refresh the Browser tab every 30 seconds. As we see, the browser still has the cached site showing the AWS logo. Since we've shut down services to this site, our browser needs to be refreshed. As the browser refreshes, we see a message stating that the services gateway is not available. The services gateway acts as a traffic officer, directing traffic to remaining online systems. This begins a quick discussion of RTO, recovery time objective. ZeroDown has a run RTO under 90 seconds. Once the services gateway confirms the persistent path is offline, it then redirects to remaining systems automatically. In our demonstration, the services gateway will connect to the application at ZV Site 2, and establish this site as the new persistent session. We can now see that our system has recovered, with the new persistent session as ZV Site 2, displaying the Microsoft Azure logo. Let us now create a new transaction. Once again, we select the Contacts tab. This time, we will create a new healthcare provider. We will create an entry for Green Valley Hospital. Select Other for the type of entity, and save the changes. Selecting the Contacts tab, we can now see our new entry. We can verify the entry by selecting the Browser tab to ZV Site 2. Here we confirm that Green Valley Hospital was processed in ZV Site 2. Furthermore, we see that Green Valley Hospital was not processed in ZV Site 1. We select the Browser tab to ZV Site 1 and confirm the AWS logo for this site. Since Node 1 service is down, the transaction was never replicated to ZV Site 1. ZeroDown software targets an RPO or recovery point objective of 0. ZeroDown software provides this function in conjunction with an internal journal eng function. To demonstrate, we will reset the Node 1 services through the circuit breaker. Once the service gateway detects the recovered system, it will then attempt to resynchronize the application at ZV Site 1. In our demonstration, the services gateway detects that the ZV Site 1 application is back online. ZeroDown software then resynchronizes the transaction for Green Valley Hospital to ZV Site 1 application. As we see, all this happens in the background automatically. This concludes our video on deploying a ZeroDown software SandBox environment. Thank you for watching. ZeroDown software provides business continuity in a multi-cloud environment. Congratulations, you are now free to roam about the clouds. For more information, visit us at ZeroDownSoftware.com.